Hello everyone, welcome back to our channel. In this video, we are going to solve the K-map SOP problems from 2 variables up to the 5 variables. Before getting into the problems, we must understand some of the definitions. The first definition is about minterm. In SOP, we all know that we are going to sum all the product terms in the equation. In that case, if each product term which having all the variables which is inside the function, then it is called as a minterm. Here we took the example f of a comma b comma c is equal to abc plus cb plus bac. Here we having only two minterms, that is abc and bac, because these two product terms having all the variables which is inside the function, that is abc. But cb is not a minterm here because we don't have a variable. It having only the b and c variable. So the minterm is a product term which having all the variables inside the function. It is called as a minterm. The next definition is about the canonical SOP. The logical function of SOP is called as canonical SOP only when all the product terms are minterms. Here we have the example f of a comma b comma c, which is equal to abc plus acb plus bac. Here all the three product terms are minterms because they are having all the variables inside the function. So in that case, the entire function of f of a, b, c is called as canonical SOP. Now let's move with the problems. First, let's move with the two variable problems. Here we have the first problem f of a, b, which is equal to summation of 0, 2, 3. We already know that in order to find the number of cells required for the K-map, the formula is 2 power n. Here we have the two variables, so that n is equal to 2. Then 2 power 2, which is equal to 4. Now we have 4 cell K-map. Here we consider A as the rows and B as the column. In SOP, 1 is the dominant term. So, as given in the question, summation of 0, 2, 3, we need to put 1 at the places of 0, 2, 3 as given in the problem. So, first we need to put 1 at the cell 0. Then the second one is at the 2. Then at 3. The remaining cell should be filled with 0. Now let's move for the grouping. While grouping, always remember, the grouping always should be in the powers of 2. In 2 variable K-map, we can able to group 4 cells at a time. But in our problem, we don't have all the ones in all the cells. So we can't able to go with the 4 cell group. So let's move with the 2 cell group. Here we can able to group the 2 cell. Let's first consider the cells 0 and 2. Here we can group these 2 cells. Next, we can group 2 and 3. So by this, we covered all the ones in the K-map. Now, let's name these groups. In the first group, we don't have A as the common in both of the cells, that is 0 and 2. But we have the common, that is B bar. So we are going to name that cell as B bar. In the second group, we have the cells 2 and 3. Between these two cells, we don't see any common in B variables, that is B bar or B. But we are seeing the common A. So let's name this group as A. Then after solving the given question by using the K-map, we are going to get the final expression as f of a, b, which is equal to B bar plus A. Now let's move for the logical implementation for this expression. So as per the final expression, we need to add the two terms that are B bar and A. So we need a OR gate for this. For the OR gate, the first input will be B bar and the second input will be the A. Then the output of this OR gate will become B bar plus A. This is our final expression, what we got after solving the K-map. Then this is the logic circuit for that expression. Now let's move for the 3 variable problems. In 3 variable, we have the question f of a, b, c, which is equal to summation of 0, 1, 2, 3, 5. Here we have 3 variables, so that n is equal to 3. So as per the formula, 2 power n, which is equal to 2 power 3, and we have the 8 cells. So we need 8 celled K-map for solving this problem. Here we have our 8 celled K-map. For rows, we are considering A, and for columns, we are considering B and C. Now, we need to put logically high value, that is value 1, at the respected cell numbers which is given in the question. Let's first put 1 at the cell number 0, then cell number 1, cell number 2, cell number 3, and finally at the cell number 5. So we have the 3 cells which are empty. So fill that empty positions with the logical low value, that is 0. Now let's move for the grouping. The grouping should be done in such a manner that we must get the higher group values. Here we are seeing 4 ones at the top. So we can able to group those. Now we have 1 at the cell number 5. Now we can't able to consider the cell number 5 alone. We must consider the cell number 1 in order to take the larger and higher possible grouping value. Now we are grouping the cell number 1 and cell number 5 together so that we are going to get 2 variables in this group. Now let's move for naming the groups. In the first group, which is marked in red, we don't see any common between the columns, but all the variables in that group are in the same row. So we can able to consider A bar as the group. Now in the second group, we are having the 2 variables which are present in different rows, but in the same column. So that we are going to consider B bar and C as the group name. So the final expression will be f of A, B, C is equal to A bar plus B bar C. Now let's move for the logical implementation. In the final expression, we have the 2 terms. The first one is A bar and the second term is B bar C. These 2 terms are added together by OR operation. So let us take B bar C for first. Here we are considering the AND gate which have the input B bar and C, so that we are going to get B bar C as the output from that AND gate. Now we need to add the output of the AND gate with the A bar. So we are considering the OR gate, where OR gate having the inputs A bar and the output of the AND gate. So the output of the OR gate will be A bar plus B bar C. So this is how the logic circuit of this problem will look like. Now let's move for 4 variable K-map problem. In the 4 variable K-map problem, we are having the problem statement as f of A, B, C, D is equal to summation of 2, 3, 4, 6, 11, 12 less d of 10, 13, 14. This d of 10, 13, 14 which represents the don't care values. So let's move with the solution. Here we have 4 variables, so that n is always equal to 4. Then we are going to get 2 power 4 which is equal to 16. Then we need to have the 16 cells in the K-map. Now this is how the K-map of 16 cells will look like. Here we are considering AB as the rows and CD as the columns. Now let's fill the values of the summation. First we need to put 1 at the cell number 2, and next at the cell number 3, cell number 4, cell number 6, cell number 11, and last at the cell number 12. But it's not end here. We still having the don't care values. So we need to put the don't care values at the positions cell number 10, cell number 13, and cell number 14. The remaining cells will be filled with the 0. Now let's move for grouping. In the cells, can you able to analyze how we can able to get the grouping so that we are going to get the simple expressions at the end? Okay, now let me see how we can able to group. Here we have the possibility of taking the quad group. Here I am considering the cell 4, 6, 12 and 14 as the one group, so that we are going to get 4 cells in a single group. Now let's move for the second group. For the second group, I am considering the cell 2 and cell 3 along with cell number 10 and cell number 11. We can able to group like this. Here we are not grouping diagonally. We are just following wrap-around grouping rule. Okay, now let's move with naming the groups. Now let us consider the first group. In the first group, we can able to see B as common between 2 rows. And with respect to the column, D bar is considered as common between 2 columns. So we can able to name this group as B D bar. Now let us consider the second group. In second group, we can able to see the common between 2 rows as B bar. And with respect to the columns, C is common between the 2 columns. So we can able to name this group as B bar C. So the final expression will be like f of A, B, C, D which is equal to B bar C plus B D bar. Now let's move for the logical implementation. At the final expression, we having the 2 product terms. The first one is B bar C and the second one is B D bar. First, let us take these outputs. Here we are having the two AND gates. The first AND gate taking the inputs as B bar and C, so that it gives the output as B bar C. The second AND gate will take the input as B and D bar, so that it going to give the output as B D bar. At the end, we are going to give the output of these two AND gates to the OR gate, so that we are going to get the final expression. After giving the inputs to the OR gate, we are going to get B bar C plus B D bar as the output. So, this is how the logic circuit and the final expression for the given problem. Now, let's move with the 5 variable K-map problems. Now, for the 5 variable K-map, we have the problem statement as f of a, b, c, d, e, which is equal to summation of 0, 2, 4, 6, 9, 11, 13, 15, 17, 21, 25, 27, 29 and 31. Here we having 5 variables. So, n is always equal to 5. Then we are going to get 2 power 5, which is equal to 32. So, in the K-map, we are going to see 32 cells. This is how the K-map of 5 variables will look like. It is having the 32 cells inside it. You can able to see the red line in the middle of the K-map, which represents that when you go for the grouping, you can able to consider the mirror grouping also. You can able to understand this mirror grouping when you go for grouping the cells. Now let's fill the logical high values in the cells with respect to the problem statement. Now let's fill the logic 1 at the cell number 0, 2, 4, 6, 9, 11, 13, 15, 17, 21, 25, 27, 29 and 31. And the remaining empty cells will be filled with 0. Now let's move for grouping. Here you can able to see when you fold the K-map exactly at the mirror line, half of the K-map will overlap on other half of the K-map, so that we can able to group the cell numbers 9, 11, 25, 27 along with the cell numbers 13, 15, 29 and 31 as a single group, so that we are going to get 8 cells in a single group. Now you can able to see the cell number 0 and cell number 2 are the opposite corners. In the same way, the cell number 6 and cell number 4 are opposite corners. When you fold the K-map, we can able to group the cell number 0, cell number 2, cell number 6 and cell number 4 as a single group, so that we are going to get 4 cells in a single group. Now we have the logical high value at the cell number 17 and the cell number 21. We can able to group these 2 cells, but we must always consider and go with the large grouping, so that we can able to consider the cell number 25 and 17 along with the cell number 29 and 21 as a single group, so that we are going to get the 4 cells in this group. Now let's move for naming these groups. Let us consider the first group. In the first group, B is common between the second and third row. And when you go for column, we need to compare the second, third, sixth and seventh column. In between these 4 columns, we can able to see E as common between these 4 columns. So we can able to name the group as BE. Now let us consider the second group. We can able to see all the cells in the group in a single row, that is A bar, B bar. Now let us compare the columns. Here we need to compare the columns first, fourth, fifth and eighth. Between these 4 columns, we can able to see E bar as the common. So we can able to name this group as A bar, B bar, E bar. Now let's move for the third group. In the third group, we need to compare the third and fourth rows. Between this third and fourth row, we can able to see A as common. Now let's compare the second and seventh column. Between these second and seventh column, we can able to see D bar E as the common. So we can able to name this group as A D bar E. So the final expression for this problem will be like f of a, b, c, d, e, which is equal to A bar B bar E bar plus BE plus A D bar E. Now let's move for logical implementation. In the expression, we have 3 product terms, so that we need 3 AND gates. For the first AND gate, we are taking the 3 inputs, that is A bar, B bar and E bar, so that we are going to get the output from the first AND gate as A bar, B bar, E bar. For the second AND gate, we are giving the inputs as B and E, so that we are going to get the output from that AND gate as BE. For the third AND gate, we are going to give A D bar E as the inputs, so that we are going to get A D bar E as the output from that AND gate. At the end, we need to sum all these product terms. For that, we are giving the outputs from these three AND gates to the OR gate, so that we are going to get the final expression as A bar B bar E bar plus BE plus A D bar E. And this is how the logic circuit and the expression for the respected problem statement will look like. So this is all for this video. If you have any doubt means, you can able to give the feedback in the comment section. And thank you for watching the video. Let's meet in the next video. Till then, bye.